So I think we can start now. So let's start. Hello everyone, my name is Sandeep Yadav. I'm a Prime Minister's Research Fellow at IIT Bombay in Department of Energy Science and Engineering. I'm pursuing my fourth year of PhD at there. So I'm here to take the weekly live sessions that will be mostly for the numerical problem solving approach. So that will give you more insights about the course that you're already attending in the NPTEL. So today is the second class, so I'm covering most of the content that is covered in the second week. So if you have any doubt in the second week content and during the problem solving session, you can ask me, or you can write. And the previous session that I have conducted is already available, and the link is already YouTube link is already provided in the NPTEL course section. If you are unable to find, please let me know. Post a query. I will again post a link at there. So before starting, I just want to let any one of you can unmute yourself and let me know my screen is properly visible and you can see me as well as you can hear me.
Yeah, can see you, Shiva.
Thanks. Thanks. So before starting, I've just ended up in the past week with the one problem that we are solving, and that was that problem tutorial question number 2. So if any one of you having any problem in that, I can solve it because we have not solved it yet. It was a remaining problem. So I can start with this problem and then we'll see what will be the course of action for this week. So here what this problem says. Yeah. So this problem says a European country had a GDP of $116 billion. Based on the market exchange rate of US 194 billion, based on the purchasing power parity in 2018. The population was 10.6 billion. The primary energy consumption is in 2018 is given by this data is already given, like what is the million tons of oil and petroleum product imported, what are the coals imported, what is the natural gas imported, and based on that the biomass consumption was estimated to account equivalent to 2.9 millions, as you can see here, 2.9 million tons oil equivalent. And the installed capacity of thermal coal power plant is already given, hydro is given, and the total annual gross electricity generation is given already. The country's import of to a total of 7,500 gigawatt are from its neighboring countries. So it's not wholly generated, it's also importing the energy. The auxiliary power consumption of the different kind of power losses and the transportation and distribution losses given. So now they're asking that draw an energy balance for the country, compute the shares of different energy sources of primary energy mix, what percentage of primary energy is used in the power sector, what is the percent. So let's solve this problem one by one, then we will just see what to do next. So let me just so here what are the things that is given. Things that are given is GDP, that is $116 billion, and purchasing power parity of $194 billion. These are both the things are given in the 2018 context. Now population is 10.6 million. Now first thing that is asked, what is the first thing that is asked is draw the draw an energy balance that will draw what percentage of the primary energy is used for the power sector. So let's try to solve the first part first. Now we know the oil and petroleum is 19.2 million tons. I can write it empty, and NCV is already given is 10,000 kilocalorie per kg. NCV is normal calorific value, and second thing is coal, which is 5.6 million tons. Here I am writing what is million tons, so if you go through again, then you might not be confused. MT is million tons. Here NCV of coal is given as 7,000 kilocalorie per kg, and gas is given 6 billion meter cube, and NCV of gas is 9,400 kilocalorie per kg. Now fourth thing is biomass. Biomass is given 2.9 MTOE. MTOE means million tons of oil equivalent. That is, biomass is converted to as a unit that is more related, million tons of oil equivalent. So these are the just unit conversion you need to take care of. Now fifth and final thing is given hydro. Hydro is 7,500 gigawatt hour, and efficiency is given 0.8, that is 80%. So now what is the total installed capacity? Total installed capacity we can calculate from coal plus gas will be 7,200 megawatt, and hydro is 4,000 megawatt. So these are the things that is already given in the questions. Now total electricity generation, total electricity generation is 46,575 gigawatt hour, and out of which import is 7,500 gigawatt hour. Auxiliary consumption, or we can say aux consumption, is 2,000 gigawatt hour, and transportation and distribution losses are 4,200 gigawatt hour. So these are the things that we can claim from the question, that these are the things that we are given. Now first thing that they're asking is, what is the primary energy consumption? So primary energy consumption A from the oil and petroleum is 1.8 into 10 raised to power 9 into 10,000 kilocalories. So how we have calculated this? We have just multiplied what is the amount of coal is being used and what is the calorific value that we have just seen here. So if you see here, calorific value is this thing we are given, and we've just what is the primary energies consumed. So that will be 1.8 into 10 raised to power 13 kilocalorie. Second is coal. Coal is 9.6 into 10 raised to power 9. What is the calorific value? 7000 is given. So you can calculate here is 3.92 into 10 raised to power 13 kilocalorie. Now moving ahead. Similarly, we can calculate for the gas also. Like other thing is gas. Gas is 6 into 10 raised to power 9 into 9400. That is the calorific value. Kilocalorie into half. 5.9. Sorry. 5.64 into 10 raised to power 13 kilocalorie. That will be 2.82 into 10 raised to power 13. Similarly, I'm not going to calculate for the biomass and hydro. You can just calculate it from here because it's going to a lot of time consuming. So I'm just writing directly biomass. Biomass will be 2.9 into 10 raised to power 13 kilocalorie, and hydro will be 8.07 into 10 raised to power 12 kilocalorie. Second thing question asked is what percentage of primary energy used for the power sector. So the total primary energy consumption, if you will see, total primary energy is 1.2. So I'm just total primary energy is the sum of all the energies that we have calculated, like from the petroleum, coal, gas, biomass, and hydro. So it's just a combination, summation of this. So it will be total 1.2147. So it is asking how much percentage is consumed by the coal, how much percentage is consumed by the generated by the coal, how much by the oil and petroleum. So we can just simply calculate that we have just calculated in the previous question. The oil and petroleum will be 14.7%, coal is 32%, gas is 23%, biomass is 23.7, and hydro 6.59%. If any one of you having doubt, I can just hear it here how this percentage is calculated. It's just simply, if you will see, I will just calculate it for here for hydro. If you will see, total generation is this, hydro is this one. So if you will see 8.07 10 raised to power divided by 1.2247 into 10 raised to power 14, the total percentage will come 8.07. Yeah, it will be 0.0659. So it is similarly coming like this. So now it's clear how this percentage is calculated. So these all the things are same. Now moving ahead, total primary energy. Total primary energy total primary energy is from the power sector. If you will see, the power sector is the addition of 5.07 plus 2.9 plus 5.63, that is we have calculated here. So if you will see total consumption of what the question is asking, let's see what percentage of the primary energy used for the power sector. So total primary energy is hydro is 0.8.07 into 10 raised to power 12, 2.09 into 10 raised to power 13, 5.64 into 10 raised to power 13, 3.92 into 10 raised to power 3, 19.2 into 10 raised to power 13. So that this sum of all these is 13.467 into 10 raised to power 3. I'm just going very fast, not very fast. I'm just going because a simpler question we have already solved in the last week. So I'm just going to cover more the things in this section. So it's just a revision of whatever we have just covered. So this is the total power sector. If you will see, is 37.7%. So now the next thing that is asked in the question is transportation and distribution losses. That is 4,200 is already given, and we know what is the overall generation, that is 5407 minus 2000, and if you will multiply that thing is 1000, that will be around 8.065. The simple things that you can just a calculation can be done in the basic mathematics. And if you will see the next part, what is asking what percentage of efficiency of thermal power plant and coal power plant, what is the plant load factor, and the thermal and hydro plant. So let's see. Net consumption, is 47875 gigawatt hour. These are all the things that are given in the question, and we have already written. Total primary use is 32, as we have seen here. Here it is 30. Sorry, here it is written. So if you will just write it here, that will be 32.467 into 10 raised to power 13 kilocalorie. Now population is 10.6 into 10 raised to power 6. 10 raised to power 6 converts to the million that we have calculated. Now per person primary energy consumption is 4.52 megawatt hour per person. And if you will convert this thing into the kilocalorie, so we can just see the basic 30629.245.28 kilocalorie per person. Now what amount of energy is going in the imports or coming from the imports? That is 7500 gigawatt hour. That is the next part of the question. If you will see here, G. Now we have calculated this F thing here. What is the if you will see, this thing is all the things. Now what percentage of imports is primary energy mix? Comment on the options should adopt for the energy security. And the last thing is the compute the energy intensity for the economy. So that's a important thing. So if you will see here, net imports is now if you will convert that into the kilocalorie, it is 10 raised to power 6 into 3.6 to 10 raised to power 3 on 4.18 kilocalorie divided by 1.2247. that is a total energy. So that comes out to be 5.27%. that are the imports. Now H, that is I think the energy intensity. So energy intensity we have just calculated in the short questions. How it is calculated? Energy intensity will be units of energy divided by GDP. So GDP is given, units of energy we have calculated 47875 into 10 raised to power 9 watt hour, and 116 into 10 raised to power 9 dollars. So that these things will come out to a 412.72 watt hour per dollar. That is the energy intensity. So now we have calculated all the parts that is given in the question. If you are having any doubt, I can just cover it for you. Otherwise, we can just move ahead to the next problem. So if any one of you having any doubt, you can ask in the chat box, so you can unmute yourself. So I'll just give you the brief. We have just, here are the things that is given in the questions. We have to calculate the installed capacity. We have calculated the primary energy consumption. After that, we have calculated the total primary energy that is consumed, total energy from the transportation, the distribution losses, total net consumption, after followed by the imports, and energy intensity. These are all the things we have calculated. So moving ahead to the short question. Before moving ahead, I just wanted to give you the brief about what we have done in the past week. I hope I have not seen any questions in the chat box till now. I'm assuming that nobody is having any doubt. If you still have, you can just solve it, or you can ask in the chat box if you are not comfortable in asking. Because these all the sessions are primarily to solve your doubts regarding the problems that you are facing in the quizzes or the understanding the concept. So if you solve the numericals more, you will get the more clarity about the concepts. So now let's see. So before starting, just wanted to give you the brief about what are the contents which are there. So let's start. So these are, if you want any detail about the things that I'm sharing right now, you can just visit the YouTube videos or the NPTEL videos that's already taught by the Professor Ranga Banerjee sir, and you can just see more details about that. So I'm just giving you what are the things like quality of life. So generally, quality of life depends on the various parameters that we see. So these are the parameters like GDP per capita or purchasing power parity. So these are the things that is for the India, as explained. What is the comparison between there are many countries, many states in the India, which are just if you see GDP per capita, so their values, mathematical values are just equivalent to the different countries in the world. Like if you see the Bihar, that is 1,333, that data is around 2015, and we will see for Delhi, that is 9,113, that is for the equivalent about the China. If you see more details, you can see that this graph shows the various states of that can represent the GDP per capita from 2013 to 15 if you compare the different countries of the world. Now the quality of life depends majorly on the Human Development Index. Physical quality are defined by the David Moyes, like literacy, infant mortality, happy planet index, popsicle index, gross national happiness, livability index, gender related development index, multidimensional, and the gender inequality. So these are the things, but mostly we are focusing on the human development index, how it's calculated, how we can use in the numerical problems. So these are the different graphs that explain the details, like what is the illiteracy versus energy use. If you see, if you increase the, if you see the more amount of energy, amount of energy decreases if the literacy rate increases. Similarly, if we see that life expectancy is increases due to the more and more energy use will be there. Similarly, the infant mortality will decrease the energy use. So now coming to the human development index. So there are three dimensions that are used for the long life, long and healthy life, knowledge, and the decent. What is it? A decent standard of living. So the indicators that are being used, if you combine all the things like dimension index, we can calculate the indexes. That is health index, education index, and the income index. So these are all contribute to the human development index. Now moving ahead, energy and the quality of life. So energy needed for the development and improved quality of life, in which we can see that life expectancy at the birth, education, literacy, infant mortality, income, or GDP per capita.
Sir, I have a question, sir.
Yeah.
Sir, actually, in this assignment, the Human Development Index and Health Index both are same in terminology, or like they are different? Like a Human
No, they are
Development
different.
Index, they are different. No? Means the formulas for calculating human development and health index are different for applications. No?
Yeah.
Thank you.
I will explain this thing in more detail when I will solve the calculation of the human development index in the numericals.
Okay. Okay.
Now the human development index dependent on the education, real GDP indexes. So index is basically actual minus minimum upon maximum minus minimum. So these are the formulas that we are going to use. I will explain more detail about these formulas, how to calculate SDIs in the when we solve the numerical after this slides. And this is whatever the formulas that already explained in the videos by the sir also. You can go if you want more details. So the SDI calculation is calculated for the Germany and China. So this is an example. 2013 example is taken. Now coming to the India, that is the old data around 2012. If you will see, human development index of India is 0.583. So now it is increased. So SDI calculation is, if you can see, initially it was the sum of all the indexes that we have seen, like health index, education index, or income index, and we can divide by 3 and get. But now it is improved to that, and this is the formula. We can use the cube root of all the things, like indexes of the life, indexes of education, index of the income, and we can take the cube root of for the calculation of the SDI. So example is taken for the Ghana, and after that, these are the like example that solve what is the how can we calculate the life expectancy. That is, if you see here, that is minimum. If you will see, just a minute. If you will see, minimum minus, that is the actual minus minimum, and the maximum minus minimum. These are the same indexes. If you see the standard formula for the calculating any index, so this is the index actual minus minimum and maximum minus minimum. So in that way we can calculate life expectancy, education index, income index, and finally we calculate the human development index. If you know already know what is these three indexes, we can directly calculate the human development index. So these are the different graphs, that is the energy consumption versus SDI. What are the factors that affect the human development index? Moving ahead. So these are the one state that's explained, that is Maharashtra, how the SDI is going for the different districts for the Maharashtra. Now moving with the same thing. So if you will see this graph, this is a total primary energy supply versus HDI. So if you will see in India, from India is increasing total, HDI is increasing from 0.42 to 6.5 from the coming years, when the total primary energy supply is increasing. So if you will see, this graph is from the 0 to 50. This graph is increasing very steeply from the India and China, and after that, that graph is going more of like straight line. So that means After that, we achieve some limit, then we will not have more and like energy intensity increases, but the human development index will remain constant, as because of that we have already achieved certain luxury of life like education, health, and uh, what we will say that income. So these things was already increased. So these things will not impact more when we increase the uh, total primary energy supply. So this is the same thing, SDI versus per capita carbon emissions. Now, if you see the gender inequality index, like health, empowerment, labor market, uh, uh, how much like men and women are distributed in the different sectors of industries, like what are the indicators that has been used in the labor market, health market, empowerment. So these are the things that has been used. Oh, this is the examples that is given. Now, second thing is for this week is energy inequality. So an energy equality we can calculate by there's a standard term, the graph that is used, that is Lorentz graph, or we can call it Lorentz curve. So if you will see, if you will divide the top 10%, if you will see what is the top 10% of a national income share across the world, so we will see, if you will see go to India, that 55% is total is income is shared by the top 10% of the Indian population. That means that this is called the energy inequality. And similar, this 55%, 10% will people will emit more and more emissions because their energy consumption will be higher. Same thing for the different countries is given. And global inequality. So the Lorentz curve, sir has explained. I will explain it in the details while solving the numerical. So it is there's a one line that is a straight line. If you will see here, that is a straight line. This line is called a line of equality. So whenever down, that is called energy inequality. So if you will see, this graph is majorly from the downside of that this from the line of equality. Whole function varies between 0 to 1. Now for that calculating this Lorentz curve, we have a coefficient called Gini coefficient. So Gini coefficient is A upon A plus B. So A here is the total area, if you will see, that is the total area. And if you will see the Gini coefficient will be calculated A upon A plus B. So that will be the total area will be A plus B, and this is the inequality we will see. So that in that way we can calculate what is the Gini coefficient. So what is that represented the total, what is the percentage terms of the inequality. So what should, I just wanted to ask one question here. How should be the Gini coefficient? It should be more or it should be less? You can just unmute yourself if you want to answer. Yes, I'm just asking. Ideally, Gini coefficient should be more or it should be less?
More, sir.
More.
Why so?
If Gini coefficient is more, then it will derive from there. It can derive the condition is not good. It will be worst, and if it is yes, if it is less,
So,
then condition is good.
So I think you're just a bit of confused because I've already told you that Gini coefficient shows how much percentage of inequality is there. So if the inequality will be more, Gini coefficient will be more. So we are trying to move to the energy equality. So if the value of the Gini coefficient will be more, there will be more inequality in the energy and the income of the top 10 or top 20% of the below 10%. So ideally it should be like a straight line, but it's a difference between the ideal and the actual condition, that's called Gini coefficient. So it should be as less as possible. Okay.
Yes, I tell this thing. I have told that if the Gini coefficient is more, then the condition, whatever condition, it will be more poorer or worst condition. and
Yeah.
when it is less, then it is a good condition.
So this is the formula of Gini coefficient. So 2 into summation of x minus Lx upon dx. This is just a mathematical representation of this, and this is the Gini coefficient calculation. If we will, so I will explain this formula when we derive the numericals, because it is the area of trapezoidal. If you can just see. In that case, if you see the whole world's Gini coefficient, and this is the graph that's shown. And now, moving ahead, I will solve this problem, energy and energy equality. So this is the, if you will see the Gini coefficient of the, this is the equality line, this is the electricity use. We can draw Gini coefficient for the various things like final energy, purchasing power parity, GDP, or the electricity line. So it shows a more or less same graph for all the things, but it is mostly the downward curve. And these are the examples of different countries, and the carbon emissions we can also draw Gini. That's if you want more detail, you can visit this paper that it will be given in the reference sections. Now moving ahead, the energy security. So what is energy security here? Energy security is how secure is our energy system. So majorly it depends on robustness, sovereignty, and the resilience. As Sir has explained already, I will not go into detail. Robustness, like energy security, is the uninterrupted provision of vital energy services, and it is the most priority for the every country. So energy security means, like if you will see the first thing, robustness. What is the sufficiency of the resources? How reliable is our infrastructure? If you see the sovereignty is what is the protection from the potential threats. Like if the Gulf countries stop the supply of all, how much sovereign is our system from there. And the resilience, ability to withstand the diverse disruptions like recessions and other like tsunamis and other things. Like how can we withstand in our energy systems? So this is the, if you will see this, this graph is already explained, so I will not go in detail. Now let's move to the numerical problem, so that will give you more clarity. If you want any other details in about these topics, you can just go through the search video. This is already explained. Now moving ahead. So I'm just starting with a small question that will give you some clarity about like objective ones. This similar type of questions is asked in the weekly quizzes, and similar type of questions will come in the some exams also. Now, if you see here, what among the following is not a quality of life? So you have to answer with me. I just don't wanted it to be solve it alone, because I'm seeing lots of people have already joined. So I just want answers from which among the following is not a quality of life index? GDP per
B,
capita,
sir. B, sir.
Happy Planet Index, Human Development Index, or Popsicle Index. So as far as I remember, or you have seen, Popsicle is the part of that. Human Development Index is a part of it. Happy Planet Index is a thing. Only if you will see GDP per capita, that was not a part of quality of life.
So what is this
Because
Happy
GDP,
Planet Index?
Happy Planet Index, how much happy is the planet? There's an index. If you will, I will show you the. I can just let me just show. So there are the indexes that has been given. I think I'll just explain this thing. Yeah. So there's an index, quality of life index. There's a Happy Planet Index. So if you will see what is asking, there is no thing that I've discussed about the GDP. So the right answer for this will be GDP per capita. You have to be careful what is the, because all the things are similar when you go through, but you have to because GDP per capita, it reflects, let me just explain, it reflects the economic output. Economic output of country. And quality of life, if you what is asked, quality of life, this thing explains other factors like health. So health will come in the human development index. Other factors like health, safety, education, etc. So the right answer will be GDP per capita. Now moving, if you are having any doubt, you can ask. Otherwise, I will move because we have not many questions. Now the which among of the following combine to form a human development? That's very easy. I think all of you must answer this. Education index, happiness index, health index, income index. There's a multiple choice question. You have to select more than one options. Just answer quickly.
Happiness index, health index,
just happiness index,
and education index.
So if you will see, just happiness index is not a part of HDI. This is a okay. If you will see, education index shows health index and the income index. Income index shows the quality of life, quality of like luxury. Health index is the basic. It shows the literacy rate. Happiness index is not a part of HDI. If you will see that formula, H is equal to whatever the formula that includes the education index of HDI. HDI was a index of education 1/3, index of health, and index of income. So there will be no. So answer will be happiness index. Now moving ahead, what would be the shape of Lorentz curve if there was an absolute equality? Now this is also I've just explained it. What is the slope of Lorentz curve? If there is absolute equality.
Option C. Option C.
So if you will see in this graph, this is the graph. If you will see, like I've just draw it, the Lorentz curve here. This was the curve. This is the line of equality. This is the line of inequality. So when Lx is equal to 1, that means this case when all the income is contributed by the 100% of the income. So that is not a case that will say when the absolute equality. No, that is inequality. Absolute equality will be Lx is equal to x in the C case. In case of absolute equality, the Lorentz curve follows the 45-degree line. That is this line. Okay, so the right answer will be Lx is equal to x. It implies that the wealth is distributed among all the population equally. And what if you are you having any doubt in that?
So what will be this curve for Lx equal to 0? Just can you just
Lx will be 0 when all the like Lorentz curve will lies between the Lx is equal to 0 between the Lx is equal to 1. L1 is at 1. So between this is the condition of 0, Lx is equal to 0. This is the condition of Lx is equal to 1, and this is the condition of Lx is equal to x. That means it's a graph when all the income is distributed equally between all the population. This case shows income is distributed to the only to the top, only for the one person is having all the income. Here 0 persons are having zero income, and between this is the graph that shows the all the income is fairly distributed among the all the people of the country, or people of a city or whatever size. Yeah.
Yes, sir. And the combination of these three lines gives a triangle. So is it like the area which will be formed under this triangle? So is it did give some absolute one, like what will be the area if one wants to draw the area of that triangle? So is it give some as additional quantity for that? Is there any?
Yeah, you're right. So that thing, if you calculate the Lorentz curve, so ideally it is the curve that shows like this type of dotted points. So if you will calculate the total area of this triangle that you're talking about, so you have to calculate the area of this area plus this area plus this area. So these are not a triangle; these are the trapezoidals. So that's why we use the area of trapezoidal case. Okay, and if you will see that first point here, if you want to calculate this area, that will be the area of triangle, and last point also that there will be area of triangle. Okay. I hope this solves the question. Now moving ahead, let me just. Okay. Now the other thing is the Lorentz curve for the countries like pink line, blue line, and the red line is given in the following figure, arranged in the order of increasing equality. Now this is a very easy question. Which country is having more equality? A, B, or C?
C.
A has more
This is
equality, sir.
A has more equality. That means A will be the most equal thing. So that it should come last. So we can just solve it from the option itself. B is more unequal than the A. So B will come in the middle, and C will be the more inequality. So that's why option is C. I hope this thing does not need any explanation now. Okay. Now moving ahead. This graph I've shown you. Which of the following statement is true with the respect of the following figure? You have already seen this figure. Now, the primary energy use and SDIs are directly related in the initial years of the country's development. Is it true? Yes, it is true. If you see initial primary, this is a total primary energy supply. So the primary energy use and SDIs are directly related in the initial years. This is true. Now option B is beyond a certain level of development, further use of energy does not make much difference in the development index. Yes, if you will see here the case of Japan or US or Spain, if you move to a certain level, then there will be no more or less very less contribution of the energy supply to the SDI. Yes, this statement is also correct. Now the final C, US and Japan have similar level of development, with Japan using less energy. Yes, if you will see the human development index, these are all having the same HDI level, but US is consuming more energy for the same HDI index. So this statement is also correct. So the answer will be all of above. Right? Okay. Now let's move ahead. Increasing the demand of oil import is a risk to the energy security of India. This is true or false?
False.
Any other people want to answer this? If they just open to the question, that will solve your queries more easily. True. Yeah, answer is correct. True. Why so? Let me explain. Increasing the demand of oil import is a risk to energy security of India. Why? Because if you are importing any of the energy supply from the any other country, then we are dependent on that. That means our energy security will, what factor will be affected? The sovereignty and the what is the sovereignty, robustness and resilience. So in that case, resilience and sovereignty will be affected. So that means it will risk our to overall energy security. That statement is true. So that means we are more and more, we should be more and more self-sufficient if we are seeing our overall country. Now, diversification of energy supply dash the energy security of a country. Now it is a fill in the blank. What thing should be there? Alteration of the earth radiation balance? No, this is not related anywhere from the energy security. Option B, acid rain.
Select D.
No.
So I think the options are wrong in this question. That's a mistake.
So it maybe it would be D. Diversification means as per the option given.
Just hold a minute. Hold a minute. These options are ideally. Just a
Didn't
minute.
get it properly.
Yeah. Actually, the question was having some mistake. Let me just solve it. Yeah. So if you will see the options will be does not affect, option B will be strengthens. Yeah, you can get a recording of this lecture. Option C is a risk, but in the recording you can't ask the question, so I will encourage you to attend these sessions until unless you have a very emergency condition. So now these are the options. Diversification of energy supply will does not affect the energy security. No, diversification of will affect the energy security. So this option is followed out. Strengthens the energy. Yes, it
B
strengthens
will
the.
be the correct answer.
B will be the right answer. Yeah. Now moving ahead. If a country has a high self-sufficiency ratio, that means if it imports most of the energy. It's very simple. You can answer.
False.
False. Because if we are importing, we are depending on the other country. That means answer is false. Yeah, answer is right, Selvashi. Now moving ahead. Identify the back-end black-ended spots. So this graph I've already shown in the slides just a few minutes ago. So it has a dimensions, indicators, and the dimension index. So here we have life expectancy index, education index. What is the other index was there?
D.
If you could see the options, happiness index, no, happiness index was not there. Gender index, no. Livability index or income index?
Income.
I think income index.
Yeah, this will be the income index, and here will be the GDP.
GDP.
So if you will see the human development index, it is the combination of, if you will see the dimensions, long and healthy life, knowledge, and decent standard of living. So if you will see the long and healthy life, it will come from the life expectancy index. If you see the knowledge, it will come from the education index, and if you see the standard of living, standard of living means GDP. GDP reflects the per capita income, how much income is one person is generating in that country, average income. So that will come from the income index. So this slide summarizes the what is the SDI. I hope this solves the questions. Now moving ahead, according to the Chicharp and Joel, that this is the paper that is given in the reference. Which of the following is not a direct theme or a perspective of energy security? So if you remember, there's a graph which was representing this kind of thing. here the energy security which depend on three things. So you need to answer this. Resilience was a part of that, yes or no?
Yes, I think, yeah.
No.
Yes, resilience was a part of it. It was resilience. Other thing is sustainability. If any other of you want can't unmute yourself, you can just write the answers in the comment box also. I'm just seeing the comment box also. So sustainability was not a part of chirp and gel energy security concept. It was resilience, sovereignty, and robustness. These are all the three things I explained in the details. So answer will be A, C, and D. No, sorry. Answer will be which is not a theme. So here, if you asking not a theme, so answer will be sustainability. Now, what will be the impact of large-scale adoption of electric vehicle on a country's CO2 emissions? So it's asking what will be the impact of large-scale adaptation of EVs. So it will increase the country's CO2 emissions.
B, sir.
B.
It will reduce the country's CO2 emissions. It does not affect the country's CO2 emissions. No, it will affect. So C will be the increment or decrement CO2 emission depends on the electricity mix. So we can't say it will increase or decrease, because if you will see, if we having more and more electric vehicles, then it will having some load on the electricity grid, and that electricity grid will define it will how much electricity is generated from the renewable sources, now how much is still generated from the coal. So ideally, if we will see the same infrastructure that we are having right now, so it will increase the CO2 emissions because we are consuming more power to charge the EVs. But if we are using renewable sources and green sources, so it will decrease the CO2 emissions. So ideally, it will depend on the increment or decrement will depend on the electricity mix. So right answer will be D. Having any doubt? Okay, moving ahead. According to this is the same question. This is again repeated. What will be the impact of? I think this is the same slide. Sorry, repeated. Which among the following is not a quality of life index? This is the same question reframed. What is the quality? What is not a quality of life index? Answer it quickly.
GDP per capita.
Option D.
Option D, correct. Now, can a Lorentz curve be plotted for the following function? So just see, Lx is equal to 0.5 e to the power 0.5x. So it's written like 0.5 e to the power 0.5x plus 0.5 x to the power 3. Is it true or false?
Seems true.
So I think we know two conditions of Lorentz curve, that L0 is equal to 0 and L1 is equal to 1. So if you will see x is equal to 1, if you will fill this, so now I've given you a hint how to solve this question. If these two conditions are satisfied, then this curve can be plotted as a Lorentz curve. Just check it quickly. The whole equation, keep x is equal to 0 and x is equal to 1. What is the value that are coming? You can type your answer.
So option A.
It is true. Yeah. So if we'll see, the correct answer will be no. Why? It does not call. If you will see, is you will typically see e to the power 0.5 x 0. E to the power 0 is always 1, 0.5. So ideally it is not consuming as a 0. So that's why it's not following this condition, these two conditions. So this statement is false. I hope this solves your query. Now moving ahead to the numerical answer time. I think one of you is unmuted. You can please mute yourself. There's a noise coming out from your mic. Thanks. Now moving ahead to the numerical questions. Numerical questions are the questions in which options are not there. You have to just put the values in a certain range. So now it's calculate the health index of a country X given the following factor. It's all the things are given, like minimum life expectancy, maximum life expectancy, mean years of schooling, expected year of schooling, GDP per capita. You have to calculate the country's health index. So let's solve this. So if you will see, health index is any index. What is the standard formula? So index is actual value minus minimum value upon maximum value minus minimum value. So what is the actual value we are having? That is 75. 75. What is the minimum value? 20. What is the maximum value? That is 85. 85 minus minimum 20. So in that case, we can calculate the health index as 0.846. Now we can solve many other things from this table also. We can calculate the GDP GDP index, or we can see the income index in the similar manner. So that's I will leave up to you. You can calculate, you can practice all the things from this question. Now moving ahead, a country has a life expectancy of infant of birth as 76 years. Maximum value of life expectancy is birth at 80 years, and that is minimum is 27 years. Now calculate the health index. Now again, this is the similar question. I just want to answer from all of you. This is a very easy question. Actual value is given 76. Minimum is 27. Maximum is 80. Health index will be, what is the formula? Just you can see here quickly. Actual minus minimum, maximum minus minimum. You just need to you please keep your calculators with you while attending these numerical problems, because if I will solve all the questions for you, you will not get anything. You need to solve it with me, and then you will see how can you do this question. Any of the indexes can't be more than 1. You have to remember this thing.
Okay.
This is the basic rule. So if you will see, actual value is given 76 minus minimum value is
0.92. Sorry, sir. 0.92.
Yeah, I think you have just calculated the opposite one.
Yes, sir.
Yeah, that will be 0.9245. Even Though I know the answers, I'm just keeping the calculators with me. So you must calculate with me. 27, let quickly just check it out. T minus 27, 0.9245, correct? So
Yes,
health
sir.
index will be. So now you know how to calculate the health index, correct? Let's move one step ahead. Now we know a country has an education index of 0.6 education index here. I'm just writing. Income index is, sorry, income index is 0.47, health index is 0.07. Now you have to calculate the HDI, that is the human development index. What was the formula even for the human index?
0.66, 0.47 into whole to the power 1 by 3.
So just let's calculate it quickly. I will write the formula for all of you. You will calculate. HDI is index of education multiplied by index of income multiplied by index of health whole to the power 1 by 3, or you can write it in that way also. Index of health.
0.62.
So if you will see 0.66 multiplied by 0.47 multiplied by 0.77 to the power 1 by 3, the value will be coming out to be 0.66 into
0.620.
0.47 to the power 1 by 3. It will be 0.6204.
620.
Yeah, correct. So now the one problem that you will be facing in how much value we should write, because if you will see this answer 0.6204555786, you don't need to write this much long answer in the numerical answer type. You can just mostly there will be a range between a given. So suppose the answer will be 0.62, so there will be a range of 0.61 to 0.63. Approximately 10% of 5 to 10% errors are acceptable in the numerical answer type questions. So you have to just answer 0.620. You can answer up to 4 digits. Up to 4 digits is always safe. Either you are attempting in the GATE exams also, it's considered up to 4 digits. Now let's move ahead. Determine the Gini coefficient of Lx is equal to x to power 3. So let's see what is the formula of Gini coefficient. We have seen in the class G is equal to 2, G is equal to 1 minus 2 from 0 to 1 Lx dx. So this was the standard formula for calculating the Gini index. Okay, so now you know we have to calculate for the x to power 3. It's a mathematical representation of that. So if you see 1 minus 2 to 0 to 1 x to the power 3 dx. What will be the other thing? 1 minus
0.5.
2, that will be x to the power 4 by 4. Limit will be 0 to 1. Now let's put the limits. That will be 1 by 4. If you will cancel it out, we'll cancel it out 2 to 4 2 times. Answer will be 0.5.
0.5.
Anyone having any doubt in this question? Ideally, you have to just remember this formula. Determine the Gini coefficient. Gini coefficient is this formula is given in the slides also. Okay. So now you know, if coming from the beginning, the theory part of it, how to calculate the human development index, how to calculate the health index, and different kind of indexes, how to draw Lorentz curve, how to calculate the Gini coefficient. So I think these are the doubts you have heard about the topics. Now let's move ahead to the long questions that will calculate, like here we know what is the we know Lorentz curve's explanation. L condition is, so it is asking determine the generalized expression for the Lorentz curve given by Lx is equal to x to the power n. So here if we have calculated for x to the power 3, so if you are having direct a formula that can, or expression that can directly calculate the Gini coefficient, that will be more easier for us to calculate. So if you will see, because when we put this, we have to calculate for the long function, we have to calculate this from the Excel sheets or Microsoft Excel, so that if the formula will be standardized, you can use it anywhere. So let's draw a detailed graph for that. So now let's see. So ideally Gini coefficient was 2 multiplied by 0.5021 Lx dx, as we have seen here. These both are the same things. I've just taken 2 as a common outside here. So if you will see 2 into 0.5, if you will further solve, it will be x to the power n 0 to 1 dx, because we have to calculate for this function. That's why we are putting x to the power n here. Now 2 into, just close it, 0.5 minus, now the integration of x to the power n will be x to the power n plus 1 divided by n plus 1, 0 to 1. 2 into 0.5, if you will put the value from the 0 to 1, it will be 1 upon n plus 1 minus 0 upon n plus 1. I hope there is no doubt in this question. This is a simple integration. If you will solve this, what will left here? Let's write 0.5 as 1 by 2. So all the things will be in the same order. This is 1 by 2 minus 1 upon n plus 1. As you can see, this thing will be 0. So now we are remaining only with these two terms. So if you will see, multiply with this 2 to 2 will be cancelled out. That will be 1 minus 1 upon n plus 1. And if you will solve this question with it will be 2. If you will solve this for the as a similar equation, it comes out to be n minus 1 upon 2 into n plus 1. Sorry, n minus 1 upon
n plus 1.
N plus 1, correct. So this is the expression that we can get it for standard. This is the, what is the question asked? Generalized expression. So this is the generalized expression. So let's check it quickly. Is it working? We have derived it right or wrong? So now we know the previous question that we have solved. X to the power 3 value is 0.5. So let's just put x is equal to 3 in the function. So let's put 3 minus 1 upon 3 plus 1. This value will be 2 by 4. So answer is 0.5. That means this is the ideal expression. Correct? So now we have proved it, and we have also utilized in the previous question. So this, if now if any one of you asking like what is the Gini coefficient for, let's do a quick exercise. What is the expression for x to the power 4? What is the Gini coefficient for x to the power 4 value? Similar to this question. Let's replace it, x to the power 4. Now we know ideal expression is n minus 1 upon n plus 1. Simple. 4 minus 1 upon 4 plus 1. 3 by 5. Ideally 3 by 5 will be 0.6. 0.6. Correct.
Actually, we have to
Similarly,
remember the formula or like derive.
You can do this. You can, if you can derive the whole equation, that will be easier. You can derive for the any of the function, but remembering the formula will be easy to calculate for the simple functions like x to power 5, x to power 9. You can simply just write answer in the simple equations to save your time. Okay, now let's move ahead. Second question: if the Lorentz curve is given Lx is equal to 1 minus 1 by x into n minus 1 upon n, determine the Gini coefficient when n is greater than 1. So this question is based on the Pareto distribution of the income, which was originally observed by the Italian Wilfredo Pareto in 1906. There's a scientist that is called Pareto. You have seen this equation is the what is the Pareto distribution, Pareto's income. So these are the things. If you want more details, that will be covered in the next slide when the energy economics will be discussed by the sir. That is the part of next week. So we are just solving it. How Lorentz curve is given. So here we can see Lx is equal to 1 minus x upon n minus 1. Sorry, this is n minus 1 upon n. This is the function. So let's solve it. 0 to 1, we know Gini coefficient is always 0 to 1 Lx dx. Simple. 0 to 1, 1 minus, ideally, sorry, this question I've just wrongly written. This question was ideally, sorry, this was a function which was written is, because in the PPT it's differently formatted, 1 minus 1 by x to the power n minus 1 upon n. So this is the formula, this is the curve that was given, equation of curve. Now we have to calculate the Gini coefficient. Gini coefficient we know it varies from 0 to 1 Lx dx. Lx we know 0 to 1, 1 minus x to the power n minus 1 upon n dx. Similarly, if you will integrate it, it will comes out to be x upon n 1 minus x 2 n minus 1 upon n divided by 2n minus 1, and this limit to 0 to 1. When we put the limit 0 to 1, that's that thing comes out to be 1, because we know here the x will be replaced by 1 minus n upon 2n minus 1. That will be n minus 1 upon 2n minus 1. So now we have similarly we have solved for the this generalized equation for the Lx is equal to x plus n. Now we have solved it for the this function. This is the Gini coefficient. So now if you want to calculate the Gini coefficient of this function, we can directly use n minus 1
why
upon.
you have taken only Lx summation of Lx upon dx?
Because Lx is the function that was given here. If you will see here, it is the function.
Gini coefficient is 1 minus 2 to the power upon integration of Lx upon dx, na? This is the main formula.
Gini coefficient is 0.2 minus 1.5.
So 1 minus 2 upon
yeah, you're right.
integration of,
Correct.
so here you only taken integration upon Lx on dx.
Correct. So now this is the value of, you're right, just missed it, 0.0 to 1 Lx dx. This is the value of Lx dx only. Now if you want to calculate the Gini coefficient will be 2 to 0.5 minus Lx dx from 0 to 1. Correct? Now
Yes.
2, if you multiply 2 into 0.5 and here 2, this value we already know, n minus 1 upon 2n minus 1. Correct? This thing will be finally just okay.
So what is this integration 0 to 1 L? Is it like it's a parameter or something like that?
Yeah, we already know how like in the graphs we have explained. Let me just solve it quickly, then I will explain what it is carrying. So it will be 1 minus 2n minus 1 upon 2n minus 1. So if you will see, the final answer will be, if you will calculate solve the whole thing, that will be 1 upon 2n minus 1. So I have the solution in the good handwriting also. I'm just solving it in the meantime. So I will share that solution also, so we can just get these things in the all the proper formats. So like last week also I solved these equations and like detailed question only for the tutorial questions. So now answering your query, we know the Gini coefficient will always be this is the Lx is equal to x. It varies from 0 to 1 only. That's why we are integrating from the 0 to 1. Is it clear? This whole function Lorentz curve is defined from L0 to is equal to 0 to L1 is equal to 1. That means no population is having zero income is equal to all income is possessed by only one person. That is the ideal
So can you
case.
repeat? Can you repeat once again? Can you repeat it once again?
Yeah. Here, if you will see the Lorentz curve, let me just. Yeah, if you will, sorry. I have to just. So, if you will see the Lorentz curve here, it is. Here. This Lorentz curve always vary. I think you can see my screen. Yes.
Yes, sir.
Yeah. Lorentz curve is varied from 0 to 1 only. That means if you can see when L is equal to 0, that means if the whole there is no income will be possessed by the no population, that will be the L0 is equal to 0, and L1 is equal to 1 is it will be the case when this graph is this single line, that will all the income will be possessed by only one person. So that's why this whole thing is integrated between 0 to 1. If you can see here also, absolute inequality will be Ls is equal to 0 when 0 axis will be 0 to 1 only, and this whole thing lies in the Ls is equal to 0 to L1 is equal to 1. I hope this answers your query.
Yes, sir.
Okay. Now let's move ahead. Now you calculated the Gini coefficient for the two different functions. Now this is the big question. Table 1 shows a given below is a data set for the residential electricity consumption by declines in the US for a given year. Plot a Lorentz curve and calculate the Gini coefficient. So this is the population. Zero population is having a zero electricity consumption, and total 100% population is having the 100% of the electricity consumption. so in which this whole Lorentz curve is lying. Now, if you will see, we are given for the different values. If you see, the proportion of the population is given by 0 to 1, 0 to 0 0.1, 0 0.2, 0 0.3, and the range of 0.1 only. And the cumulative electricity consumption, and if you see here, this 20% will be the cumulative of 0.23 also. So here it's given in the cumulative. Okay, so now let's draw this. So if you will draw this line physically, this will be the line Lx is equal to x. That means a line of equality. This is the line of equality. Okay, and if you want to draw the things that is given like 0, so this point will be the 0. If I will show you more clearly, this point will be the 0, this point will be the 1, this point is 0, this point will be the 1. Okay, and if you want to draw 0.1 value, so 0.1, if you will see here 0.1, it's already given here. I hope you can see this. Yeah,
Yes.
0.1 represents a 0.23 value. So here it is value given 0.23, 0.023, and 0.2 represent a value 0.06. So if you will draw this, ideally this graph will be this one, this one, this point. These are the points that you can see here. Okay, so now we have to calculate the Lorentz curve. This will be the A, this will be the B. Gini coefficient will be A upon A plus B. So we have to calculate the area between these all curves. Correct. So how we will calculate? Let's see. So we know this is the trapezium. Correct. If you will draw this thing here, this will be like a trapezium, and this is also trapezium, this is also trapezium, finally this is also trapezium. So we have to add up all these graphs, correct, to calculate the areas covered by this. So now let's see area of trapezium will be 1 by 2. This is a basic 8th class math. Y1 plus y2 into x2 minus x1. Area under the Lorentz curve will be sum of all the areas that we are having here. Now if you will see Gini coefficient, we know what is the Gini coefficient. Gini coefficient is 2 minus 0.5 minus area under the Lx dx will be the area under the curve, correct? So we are solving the area under the curve. So that will be 2 upon, we can write it 0.5 as a 1.2 minus. So we know this formula 1 by 2. So if you will take the 1 by 2 common from all the area of trapezium will be remain y1 plus y2 minus x2 minus x1 plus y3 plus y2 x3 minus x2, and similarly we can calculate from the all the points. So here if you will see yn plus yn minus 1 and yn upon yn minus 1, correct? Yx, sorry, x, this will be
xn minus xn minus
xn minus 1. So this is the whole thing. So if you will see in the Now we know x2 minus x1 will be, now we know here the thing, if you see, this is the x graph, this is the x, this is y. So x2 minus x1 will be 0.1, correct? If you see the gap, x3 minus x2 will also be 0.1, because this is following a similar gaps. If you can 0.1, 0.2, 0.3, so we can write here x2 minus x1 will be x3 minus x2 and x4 minus x3 similarly. Okay, this whole thing will be 0.1. So now we can also take common Gini coefficient. Gini coefficient will be, we can also take common 2, 1 by 2 minus 1 by 2, and here we can also take 0.1 as common. Now we are only remaining with y2 plus y1
X10
plus
minus
y3 plus y2 and so on, yn plus yn minus 1, correct? Because we have taken x things common. Now we have to put the, we know the values of y2 plus y1. Yes, we know. We have given the y0, y1, y2, y3, y4. So we can put all these values. And when you solve this 2 upon 1 by 2 minus 1 by 2 to 0.1, and if you will see 0 plus 2 into 0.23, and similarly if you solve this equation, whatever the values is given, the whole thing comes out to be 0.3464. So this is the value of Gini coefficient. So if you are given the values of different plots in this way, so you are also be able to solve these questions. Okay. Anyone having any doubt? Because if I will just show you this is the rough graph that I have drawn into the Lorentz graph right now. If you will see this one, but this is the actual graph of the values. If I will show you in the Excel sheet, let me just show it to you. I've drawn the actual graph also, so this will give you more clarity. So if you will see, sorry. So these are the values that are given from 0.1, 0.2 to 0.23, and this is the line of equality. What is the line of equality? Lx will be equal to x. So L0 will be 0, L0.1 will be 0.1. So similarly, this is the line of equality when with all the things are proportional, exactly proportional to this. This is the graph. If you will see the points here, if you will see this is the so that's why we have calculated all these areas under the curve right now. This is the actual graph, how it looks like. Okay, now let's move ahead to the next question. Okay. So next question is Victor. So this shows just get full screen. In a company, each of the 20 in the service department earns 10,000 rupees monthly, and other than 80 junior engineers and other than 80 senior engineers, which they earns 22,500 rupees and 37,500 rupees respectively. Each of the managers are having 2,500 in a month. So right now, if you can see, there are 4 types of employees that are working in a company: service department, junior engineers, senior engineers, and managers. Now we have to determine the Gini coefficient of the income distribution of the company. So in that way, we can also use the Gini coefficient. So let's see. So I will just solve it in the same manner that I've solved. I will just solve it in the Excel sheet. So now we can see here. This is the thing. I hope all you can see. Yeah, you can. In the company, 20 persons of 20 people are having service department. So this is the serial number 1 is service engineers. Correct. This will be the service department. Similarly, this will be the JE. This will be the SE. Sorry. This will be the SE. And this will be the managers. Okay. Now we know we have given the serial numbers to them. Now we have given the number of persons in that. 20 will be the departmental service department. 80 will be the senior engineers, and similar 80 will be the junior engineers, and 20 will be the managers. So now we will see the cumulative frequency. Cumulative will be initially we have 20 only. Now if you will add here, 20 plus 80 will be 100. So this is the addition of 20 plus 80. So if you will see the cumulative. Similarly, if you will add more 80, then it will be 180, and the cumulative final will be 200. So I know if you are having any problem, I can just solve it. I hope you get getting it. I'm just solving it in the Excel sheet because you can solve the larger problems in that way. This is the actual thing how Gini coefficient is calculated. Okay. So okay. So now we have to convert this Gini cumulative frequency to the per unit cumulative frequency. So what is the per unit cumulative frequency? Per unit cumulative frequency will be the total cumulative frequency by the individual cumulative frequency. So this will be 20 by 200 will be 0.1.
0.1. Okay.
100 by 200 will be 0.5.
0.5.
180 by 200 will be 0.9, and 200 by 200 will be 1. Now we are seeing the how the things are working. Like the Gini coefficient always varies in the 0.1 to 0 to 1. So now we are having the values of 0.1 to 1 by per unit cumulative frequency. Now we are given the absolute income. Let's put it. Absolute income was given 10,000. Okay. 22,500. 37,500 and 2,50,000.
2,50,000.
Okay. So now absolute total income will be absolute income per person into number of persons. So 10,000 multiplied by 20 will be 2 lakh. So that's how these things are coming. Absolute total income will be 2 lakhs. Similarly, 22,500 multiplied by 80 will be 1 lakh. Sorry, 18 lakhs. And similarly, this for the senior engineers and the managers. Now cumulative income is in the similar manner.
Same type cumulative.
Yeah, same type we are calculating, like adding all these incomes. Now, similarly, if you will see the per unit cumulative, so that will be 2 lakhs divided by the 10 lakhs, that is 0.02. In the similar manner, we have calculated the per unit equivalency. Now, line of equality. What is the line of equality? It's a similar thing when Lx is equal to x. So if you have to draw a line of equality, so we have to follow this equation. Line of equality will be exactly equal to the 0.1, 0.5, 0.9, and 1. And area.
Can you repeat this one? So can you repeat this line of equality?
Yeah. Line of equality, if you will see in the previous question, what is the population? So if you want to draw this
0.
line of equality will be 0, 0.1 will be equal to 0. This is the proportionate thing. So when the value will be x and y will be equal. Okay. So similar thing, x and y will, this will give us the line of equality, and area under the equality curve will be. Now we have know what is the x, what is the y. So if you will see here, sorry, if you will see y2 minus y2 plus x2 minus x1, x2 minus what is x2? 0.1 to 0. That will be
0.1.
0.1 and multiplied by x2 minus x2 plus x1 by 2. That was similarly we are calculating the area of trapezium. This one. Okay. All the areas are we have calculated here. In the last question also, pardon, I have made a mistake. This area of triangle we have not neglected. We have just calculated in this way. Like we don't have the value of x0, so we have considered it as a 0. So that area comes out to be very 0.001. That's why we have not, answer is not affected, but it is having the, now if you solve the mathematically, we don't have to ignore any other thing. So we can include all the small details in that. That's why I'm solving these Excel sheets. Okay. So if you will see, you can also calculate, like if you see the area under the curve, it is the summation of all the areas. And if you will draw this curve, like if you will draw this curve with this one, then if you will see, this is the line of equality. You can see this is the Lorentz curve. Okay, and we want to calculate the area under the curve. That will be the area under curve. That will represent the Gini coefficient. Now we can calculate the Gini coefficient. Okay. I hope if anyone is having any doubt, you can just clear it. As for the ease of application, I have also given the formulas here so that you can calculate from your own. Any doubt in that?
So this a plus b equal to 0.5, how it is coming? In the x plus a plus b in the next month, yeah.
A plus b.
Gini coefficient. A plus
yeah,
b.
Gini coefficient a plus b will be 0.5 always. Na? This is the 45-degree line. Okay. So if you see, consider it as a one area, then it will always be 0.5. A plus b is equal to 0.5. Okay. Okay, let's move ahead to the final question. The question here shows this is the multiple country question. Here it is showing that what will show you. This is the final question for the day. This shows the distribution of the total disposable income by quintile of the population of the. This is the quintile is also the fraction of population. That is the first 30%, second 20%, 32%, 42%, and the first quintile represent having a total 20% income. Compare the degree of income equality. So this is the comparison of two countries is given, and we have to calculate the Gini coefficient of both the countries. Okay, so let's solve it. Now the as we have given first, second, third, and fourth quintile. If you're having any doubt, you can just see it again. Okay, first, second, third, fourth, fifth quintile is there, and if you see the cumulative will be always 100%. Okay, let's move ahead. So that will be 0 to 1. Okay, for first quintile is given 100%. If you country one, if you want to draw a line of equality, so we are having all the values from 0 to 1. So we have just divided all the things in 0 to 20%, 40%, 60%, 80%, and 100%. So first 30% is having an income of. So if you will see here, cumulative was given 30%. Second is given for the 20%, 32%, 14%, and 4%. And if you see the cumulative was 1 minus, what is the amount left? 1 minus 0.3 will be like, what is the other population that is left here? 1 minus 0.3, that is 70%. Initially it was 100%, And if we divide 30%, that was 70%. Now 70% we have to divide, we have to subtract 32%. That will be, so 20%, that will be 0.5. In similar manner, we can just have the, so now we are drawing a graph between 0 to 1 to have a countries a cumulative quintiles. And similar way we have given that 55%, 25%, 15%, and 3% and 2%. We have to again, the 1 minus 0.45 will be 0.55. Similarly, 0.45 minus 0.25 will be
0.30.
0.20. And yes, in a similar manner. Now, line
So
of
it will
equality will be
0.30, no?
which one?
0.45 minus 0.15. This will be 0.30, no?
0.45 minus
Minus
0.25.
0.15. So 0.30, I think.
0.25. Oh, sorry. See,
Yeah,
1 minus
0.30.
0.55 will be 0.45.
Huh.
Now 0.45 minus 0.25
Oh,
will be
minus
0.
that. I'm just considering like diagonal wise. Okay. 0.5.
Yeah. So it will be like this only. Okay. Now, line of equality, if you want to draw, it will be same as the cumulative population. So if you want to draw a line of equality, this will be the equation of line of equality 0 to 1 in the similar manner, like it's directly proportional to the value of x is equal to y. And countries A's equality, we can calculate y2 x2 minus x1 into y2 plus y1. So here we can see x2 is 1, so x2 is 0.8, sorry, x2 is 1, x1 is 0.8, and y2 plus y1. So it's again we are calculating the area of trapezium, this one, and this second line shows the area of trapezium for the B country. So these are the two countries. Here we are drawing in the same Lorentz curve. So if we see the uh, things that has been asked in the question again, so it's similar like we have just solved it. Graph is similar, but we are just included one more country. Now we can compare two countries in the same graph. If we see like country A is having, which of these countries having more energy equality? This is orange curve represent the country B, and blue curve represent the country A. Now tell me, which country is having more energy inequality? Please answer.
Country B.
Country B is having more inequality. Why so? Because it is far from the line of
Far
equality.
from that
Correct?
line of equality.
Yeah, correct. So if country A is having showing the graph nearer to the line of equality, it will having a less energy inequality. Similar way, if you want to calculate the Gini coefficient, we already calculated the energy area under the Lorentz curve, that is Alex. So we can calculate the this thing 0.5 minus j minus j11, that is the this thing 0.384. So we have calculated the Lorentz curve from a different manner this way. This is the, so as we know, Lorentz curve is a upon a plus b. So this is the whole curve. So we have calculated the area b. We know this one. So in that way we have calculated this, correct? The whole area will be 0.5 and a minus b will be 0.5 minus the area under the curve. So if you are having any doubt in this question, so we have calculated both the Gini coefficient and Lorentz curve plotted. So now similar manner, whatever the question, suppose this any other income facilities or any other thing is given, you can calculate it in this way. I will share this Excel sheet also, so that you can play with the numbers. You can change the numbers and solve them as many as question as you want. If you are having any queries, you are just otherwise we will end this session today. I hope I don't see any comment section also, so I'll consider that. So if you have any specific queries other than this, so you can write down in the query section also. So I will answer it there.
So will you share this slide, like this slide?
Yeah, I will share all the slides with the all the things written on that, and all the questions will in a good handwriting and the separate papers. Okay. And the recording of these sessions will be available on the YouTube link that I will share in this. The
Also
same.
in the NPTEL site also it can be viewed.
Not NPTEL. NPTEL in the course section there will be a separate section in the. I will write it down here. That will be a lecture recorded, like recorded videos. So I will just show it to you here. If you will see. If you will see here the NPTEL. If you go to the course, just sign in. So if you'll see here on the week 1, there's a additional there's a one thing that is called there's a problem solving session in the Jan 24. You don't have to go week wise. There's a separate section, problem solving section. If you will go through it, there will be a link there. If you click here, there will be a link here. If you go through this link, this will redirect it to your last week's recorded session. Correct? Okay. And the similar manner, all the files will be uploaded in this folder. If you see, open this folder. This is a week 1 content. Go through it. All the week 1 slides are there, and as well as the tutorials solution. Okay. 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 I think we are done with this class. You can just leave it now.
Thank you.
Okay. Thank you.